Okay, let's kick this off with something that sounds, well, straight out of science fiction. The co-pilot in a U.S. Army Black Hawk helicopter, it's an algorithm now, and this isn't some future concept. It's actually being tested. DARPA, Sikorsky, they're doing it.
It really is a major moment. A fork in the road for military helicopters, you could say. We're talking about automating one of the most demanding flying jobs there is low-level, high-risk helicopter flight. And interestingly, it's happening on two tracks at the same time.
Right, and that's what we're digging into today, this cutting edge of vertical lift autonomy. So track one, the LES program, that's about putting automation into the existing Blackhawks. And track two, the Army's big future replacement, the V-280 Valor, a completely different beast.
Exactly. It's this tension between, well, integration adding tech to what we have versus outright replacement. Why automate that specific job? And, what does a helicopter look like if it's designed from the ground up without needing people inside?
Let's start with Alias then, that retrofit idea. Aircrew labor in-cockpit automation system. Sounds impressive, but what is it? Is it like a physical robot arm moving the controls?
No, not quite like that. Think of it more as a sophisticated software and hardware package, an ecosystem. Alias is built to be flexible, adaptable. You can install it in different aircraft. And the brain behind it, for the Blackhawk anyway, is Sikorsky's MATRIX system. It's essentially a full-on digital co-pilot.
Okay, digital co-pilot. And they hit a huge milestone not too long ago, didn't they? The first flight of a Black Hawk, a UH-60A with absolutely no one on board, an OPV they called it, optionally piloted vehicle.
That was the big one, February 5th, 2022, over Fort Campbell. A 30-minute flight, completely autonomous, takeoff, flight path, landing, all handled by the system. Proving that was, well, critical.
So proving it can be done. But why? What are the real benefits? I mean, besides the wow factor.
Well, people like Stuart Young, the DARPA program manager, they point to really practical stuff. First, safe reduced crew operations.
Reduced crew. Okay, that makes sense logistically. But does that cause friction? Are pilots worried about being replaced by software?
The focus right now, officially at least, is on efficiency and safety. Not necessarily replacement yet. It's about cutting down the pilot's workload. Imagine flying low, fast, in bad weather the sheer mechanics are demanding. If the system handles that, the human crew can focus on the mission itself, managing things, not just flying. That cognitive offload is huge in combat.
Right, freeing up brain space. And that allows them to fly in conditions that might have been too risky before.
Exactly. Think about contested airspace, crowded skies, or what they call DVE, degraded visual environments.
The DVE. So like dust clouds during landing, heavy rain, stuff that blinds a human pilot.
Precisely. Brownouts from dust, blinding rain, thick fog, situations where a pilot might get disoriented, even relying on instruments. The Matrix system doesn't get sensory overload. It uses its sensors, processes the data. It can potentially make flying in those nightmare scenarios safer, more reliable.
Okay, so the software brain is there. How do you actually use it? You mentioned Project Convergence 2022. How did they command these autonomous Blackhawks during those tests?
This part is pretty amazing, actually, the control interface. It wasn't someone remotely flying with a joystick like a drone. It was a ground operator using simple commands on a ruggedized tablet connected via secure radio.
A tablet to fly a multi-million-dollar Blackhawk.
Yep. Not pull left stick, but more like fly to these coordinates, land at this point, avoid this threat area. Mission-level commands, a huge simplification.
Wow. And the missions they demonstrated were pretty complex, too. That medical resupply one.
Yeah, that was impressive. An 83-mile autonomous flight, carrying 500 pounds of blood products, real and simulated.
83 miles.
Yeah.
And it wasn't just flying high and straight, was it?
No, definitely not. Part of the demo was flying low and fast to use the terrain for cover. They got down as low as 200 feet above the ground, moving at 100 knots. That requires incredibly precise navigation and obstacle avoidance,
Hold on. 200 feet, 100 knots, autonomously, with vital cargo. That's a massive leap of faith in the software. How do they trust it won't, hit something?
Rigorous testing is key. They use a mix of sensors, LiDAR, advanced radar fused together, constantly scanning and computing potential obstacles. Redundancy is built in. Then there was another mission combining cargo and case-evac casualty evacuation.
Okay, what did that involve?
Lifting a heavy external load first, 2,600 pounds on a sling, again flying fast, and then, mid-flight, they simulated a new threat popping up.
So throwing a curveball at the system.
Exactly. And the autonomous system had to react. It rerouted itself to a new landing zone, dropped the cargo, then landed to pick up a simulated casualty, a mannequin on a stretcher.
And I read something about monitoring the patient, too.
Yes, this is a key integration piece. They used a BatJack device, it's a health monitor. It sent the mannequin's vitals in real time through the helicopter's comms system back to a medical team on the ground. So the Black Hawk wasn't just transport, it was like a mobile data node for medical info. That integration is a real game changer.
That really is, taking it beyond just flying from A to B.
Absolutely. And you can see the potential beyond the military, too. Sikorsky's already working with a company called Rain. They're looking at using autonomous Blackhawks for fighting wildfires, finding hotspots, dropping water precisely, without risking pilots in dangerous conditions.
So Alias is about making the current Blackhawks smarter, more capable, optionally unmanned. But Sikorsky took it further. They asked, if we don't need the pilots sometimes, why keep the space for them? Which leads to the U-Hawk.
The U-Hawk, or S-70 UAS, it's the logical next step if you're purely focused on unmanned operations. They took an older Black Hawk airframe, the UH-60L, and just ripped out the cockpit entirely. Crew chief stations, too. Gone.
So the front end is totally different. What's there instead?
Clamshell doors and a ramp. It basically turns the whole front of the helicopter into accessible cargo space. It looks, frankly, a bit brutalist, pure function.
Wow. And that must make a difference for payload.
A huge difference. Removing all that cockpit structure gives it 25% more internal cargo room than a standard Black Hawk. Suddenly, the argument shifts. For certain missions, especially dangerous logistics runs, the cockpit isn't just unnecessary, it's taking up valuable space and weight.
25% more room.
Well,
What can they fit in there?
Well, standard cargo containers, obviously. 4 joint modular intermodal containers, but also some pretty serious firepower options. They've shown it configured to carry a HIMARS pod.
A HIMARS rocket pod.
A big
Pod of 6 rockets, yeah. Or they mention a munitions quiver for firing missiles or deploying sensors. It can even apparently drive unmanned ground vehicles, like the HTT Hunter Wolf, right up a ramp. It becomes a flying truck or a flying launch platform.
That's incredible. A cargo drone that can launch rockets or deploy ground robots. And they developed this quickly, under a year from concept to the actual debut, which was October 2025. That speed tells you how urgent the need for contested logistics solutions is perceived to be. The rationale is clear. Keep highly trained, expensive crews out of missions that are dull, dirty, or just plain dangerous.
Okay, so the U-Hawk is optimizing the current airframe for unmanned work. But parallel to all this, the Army's looking long-term, replacing the Black Hawk entirely with the Future Vertical Lift Program, FVL.
Right, and under FVL, they selected the replacement for the Black Hawk role. That's the Bell V-280 Valor.
A tiltrotor.
Tiltrotor, like the V-22 Osprey. So fundamentally different from a conventional helicopter. Let's compare them. The performance jump must be significant.
Oh, it's staggering. Speed, first off, the V-280 claims a top speed around 305 knots. It's about 350 miles per hour.
350 mile per hour. Compared to the Black Hawk, what, maybe 180 mile per hour tops?
Easily over 100 mile per hour faster, yeah. It just leaves the Black Hawk behind.
And range. That's always been a helicopter limitation. Another huge leap. The Black Hawk's unrefueled range is around 360 miles. The V-280, they're talking 800 nautical miles, more than double. Plus, more capacity, roughly 25% more cargo or 23% more troops. It's a different league.
Okay, faster, longer range, carries more. Sounds like a clear winner.
Mm-hmm.
But tiltrotors are complex, right? The V-22 had its share of issues.
That's the trade-off. They are inherently more complex mechanically. You've got engines that have to pivot, complex gearboxes, sophisticated flight controls. It's just more moving parts compared to a traditional helicopter rotor system.
And does that complexity raise specific concerns, like, say, auto-rotation, if the engines fail?
That's definitely been part of the discussion. Auto-rotation gliding safely down using airflow to spin the rotors is a fundamental safety feature for helicopters. With the V-280's design, the large proprotors and the fixed wing, how effectively it can auto-rotate compared to a Black Hawk is a complex engineering question. Bell has obviously worked extensively on this, but it's different.
And what about using it on ships? The Navy and Marines use Black Hawk variants.
Good point. Shipboard operations bring different constraints. While the V-280 is actually shorter than a Black Hawk, when those big proprotors are out, its overall width, its footprint, is wider. Trying to land on a small destroyer deck or fit multiple aircraft in a cramped hangar bay, that extra width matters. It's a logistical challenge for naval use.
Okay, so stepping back, we've got these two paths unfolding.
Right. Path 1. Maximize the huge existing Black Hawk fleet. Use Alias to make them smarter, reduce crew needs, create unmanned options like U-Hawk for specific, dangerous, or dull jobs. It's faster, likely cheaper in the short term.
Path 2, the big leap. Invest heavily in the V-280 Valor. Accept the complexity and cost for that massive boost in speed, range, and capability for the next 50 years.
And whether it's the automated retrofit or the brand new design, the core trend is the same. It's about shifting the human role, moving people away from the physical act of flying, especially in high-stress or routine situations, and more towards mission command, decision-making, managing the system.
The human becomes the strategist, the machine handles the mechanics, especially when it gets dangerous.
Exactly. Which brings us to a final thought for you, the listener. We now have the tech where one person on the ground with tablet can launch and command a multi-million-dollar Black Hawk. We also know that stripping out the cockpit makes room for 25% more essential cargo. So given that, how long before that physical cockpit stops being seen as essential equipment and starts being viewed as, well, an optional vulnerability, something you might not want on the highest risk missions?